I went ahead and took this from the AE book because I like its description. So it is not, so if you want to screenshot it from the AV book, you can, or you can just take a picture of this. Please don't write it all down. It's a lot of writing, but take a picture or screenshot it from your AV book. When we're trying to find limits, sometimes what happens is you get something called indeterminate form. Because when you're trying to find a limit, the first thing you should be thinking is, can I do some direct substitution? Maybe this problem is really easy. Maybe there's a value when you start talking about e to the x, or you're talking about exponentials. You know that there's this sort of, I don't know how much trying to describe it, but there's a battle, right, between the numerator and the denominator. Which one is growing faster? Are they growing at the same rate? And which one's going to win? Right? That's kind of how limits work. And sometimes what will happen is you can't determine it. You can't decide which is going to win. Who's going to muscle the other one, the numerator, the denominator. Okay? And so you have these things called indeterminate form. Now, what's important is, and I mentioned this early on in the year, is there's certain things that you have to show. Notice that what I've boxed up here is you have to show the individual limit of the numerator and the individual limit of the denominator. You do not want to say, because you end up getting this indeterminate form, 0 over 0, infinity over infinity, negative infinity over negative infinity, which is the same thing. But still, what will happen when you get this, then you can take the derivative of the numerator and the derivative of the denominator, okay, and then you can evaluate that limit. And then you'll be able to get somewhere with that. Please keep in mind, this is something you should never write on the exam, okay? If you write the limit of something equals 0 over 0, or equals infinity over infinity, or negative infinity over negative infinity, they're gonna look down on you and frown on you and count points off. Because these values don't actually have values. They don't actually have meaning. Okay, we say they do not exist, or we say it's undefined, that kind of thing. Mathematically, this is technically incorrect. And so they really want you to not do this. Now I'm going to show you, and I'm going to do it long, but it's going to show all of this work. And I know for some of these problems, sometimes it feels like I get it, but so what's the big deal? Well, just because this doesn't actually have meaning, it is undefined, and they harp on that one for some reason. You can truncate around, but this one they really care about. I don't know how they make those determinations, but they make them. So here's a couple examples, okay? And one of the things that's going to happen in this section, okay, you get in the habit, you get in this rhythm of using L'Hopital's rule over and over again. I always encourage you to check to see if you actually need to. Sometimes you don't need to. And a lot of these questions, a single question like this will probably be a multiple choice. If it's something that's embedded inside of a larger problem, that's when that expansion and writing it a certain way is important. And I will tell you, just in the interest of preparing you the right way, when we get to our quiz on Friday and our test next week, if you write things like limit equals 0 over 0 or equals, infinity over infinity, yeah, I'm going to take points off for that. All right, so my first question to you, and these will all be from the book and they'll have the numbers on them. Do you need L'Hopital's rule for 1? Okay? And I want you to think about that. So, what do you think? Do we need L'Hopital's rule for this? How many think yes, we need it? How many think no, we don't need it? Okay, so you all think we need it. Okay, so let's. So we're talking about infinity here. Okay, obviously, if I take and x grows to positive infinity, this numerator is going to grow to positive infinity. E to the x, if this power grows to infinity, then this denominator is going to also grow to infinity. Okay, so we have this situation where the limit of x equals infinity as x approaches infinity, and the limit of e to the x approaches infinity, it also equals infinity. So if you're looking for a little bit of a shortcut, right, they both end up equaling infinity. So from here, I can take the derivative of x, and I can take the derivative of e to the x. All right. But at some point you have to, this is how I guess I would like you to establish that you can use L'Hopital's rule. Here's what it can look like. That we end up with indeterminate form. Okay, so here's how you sort of say that it equals infinity over infinity without saying that it's equal to infinity over infinity. Does that make sense? You can write it. You're allowed to write infinity over infinity. What you're not allowed to write is that the limit equals this. Does that make sense? I want to make sure we're clear on what you're allowed to write and what you're not allowed to write. Yeah, question.
But you want us to write the part above that, right?
Yes, you establish that the limit of the numerator equals infinity, the limit of the denominator equals infinity, and therefore you get indeterminate form. Question.
Do you do the same for 0 for 0?
Yes. So yes, if these ended up both going to 0, we'd do the same thing for 0. Eliza.
So why can't we write the arrow? Because Mr. Schreiner said we're allowed to write the arrow, just not read this.
To me, the arrow and the equal sign are really close. I just don't want you to make a mistake. I'm more comfortable if you shift away from the arrow and you go here, and then there's no way you're going to be counted off there. Yes?
What if we didn't do the arrow this time, but we just put infinity over infinity? Because she said if we could do the arrow, or we could just put the infinity over infinity like next to the limit
Like a
x.
space.
Like
I would do
X.
again. Here's what I would do. I would put it on a whole separate line. If it looks close and you create ambiguity or ambivalence on the part of the grader, I wouldn't want to do that. I'm sure they're very capable, wonderful people, but I'm going to make this analogy. When I coached baseball for years and years and years, I used to tell my players, don't leave it into the hands of the umpire. Swing the bat, because the umpire might mess up. I don't want to I don't want to put my fate into the hands of somebody else. And so it's the same kind of idea. Might it be okay? Yeah. If you get it a little too close, maybe they go, maybe they, make it very clear. Just skip to the next line. You have an unlimited supply of paper here. It's no big deal. Okay. That would be my advice. Okay. So of course, now I have my limit, and then I take my derivative. And what we can see is that the derivative of x is 1, the derivative of e to the x is e to the x, so now I get, of course, 1 over infinity, which is 0. Now, if this was a multiple choice question, obviously the way that you write it all out doesn't really matter. I would argue that you don't need L'Hopital's rule here at all, and I know you guys all said we did. Okay, remember that battle I was talking about. Which grows faster, x or e to the x? E to the x grows faster than pretty much everything. Okay, so while this is growing, this is also growing, but it's growing exponentially. This denominator is going to beat out the numerator, as we've demonstrated here. Okay, on a multiple choice question, you should be able to just look at this and go 0, boom, no big deal. This is going to out muscle the top. Okay, all right. Let's take a look at the next one. So again, go direct substitution. I get a 0 on the bottom. Okay, so now right away I'm thinking, all right, I wonder if I get a 0 on the top. So if I plug 0 in here, this ends up being e to the 0. What is e to the 0? So this is 3 minus 3. So again, I end up with they both equal 0. And so I have indeterminate form again. So go ahead and find the limit using first derivative. Go. All right. So when we take the derivative of the bottom, because that's the easy one, that's 1. The top 3 drops out. Okay. The derivative of e to the 3x is 3 e to the 3x. So that's why this ends up turning into -9. Okay? And so now when I plug 0 in, All right, this all just changes to 1, so my limit is -9. Okay, how many got that? Okay, good. All right, next one. Go ahead and do this one. Just go ahead and do this one. Go. How many of you use L'Hopital's rule for this problem? Okay, that's fine. You could. I'm not gonna. So we do have indeterminate form. Okay, when I plug -1 in, I get 0. When I plug -1 in, I get 0. So that is true. We have indeterminate form. But do you need L'Hopital's rule? Like, right? Would you agree that if we don't have to use L'Hopital's rule, like the problem is easier? There's some easier way to do it? Do you understand that using L'Hopital's rule usually requires more time and effort?
I just feel like it doesn't. I don't.
You don't feel that way? Okay.
I'm so fast, Mr. Zukin.
Yeah, right. Is it a multiple choice or is it a free response? So I didn't, because right away I see what do you think that I saw right away?
Factor.
Yeah, I see this 2, and so then I go, and then right away I go, oh, I know this. This is a difference of squares. So this is x plus 1, x minus 1, which means the x plus 1's cancel. So I really just have 2 times x minus 1. You plug that in, boom, done. I don't know. Could you have used L'Hopital's rule? Of course you could have, right? And you could have you'd have 4x minus 1 over 1, and this is the limit as x approaches -1, and so you, nope, not minus 1, my bad. Goodbye. That was bad. Okay, and so then, of course, you still get -4. Does it matter which way you do it? Of course not. Okay. Last thing, just side note. How many did you get -4, by the way? Okay, good. You guys know this, okay? You can keep taking the derivative. If you do it one time and you still get indeterminate form, you can take the derivative again. If you still get indeterminate form, you can take the derivative again. Eventually, right? Because with derivatives, most of the time you're going to have some constant in there that's eventually going to drop out. You're going to get to a place where you're like, I'm good, and you can figure out what the limit is. I didn't give you an example. I'm not going to go through an example of that again, but I think you know this, and just keep that in mind as you're working through today. The other thing to keep in mind is pay attention to the directions for the problems, because sometimes they tell you, you must use L'Hopital's rule for this problem, and sometimes you don't. And if it doesn't say anything, it's up to you. You get to choose. Just kind of pay attention to that, because I think they want you to be able to understand, that struggle that we were talking about with the x and the e to the x, that e to the x, they both grow to infinity, but the one grows faster to infinity and it out-muscles the other one. Just kind of having those number sense ideas, I think, are important.